It's extremely difficult coming in the second day towards lunchtime on stage and talk about something new. So think of this being a bit of a rattle and perspectives on a technology side, but also on a process side. So in here we talk about the CI/CD, continuous integration, and continuous delivery from a process perspective. What I normally do is, yes, looking back in history, Javier has done that as well. I was not taking it from another industry, I take it really from the telecom industry. I don't remember like what time it is, it's courtesy to AT&T. The left side is really operators managed by a lady. And the automation here is that the lady wears rollerblades, that she is quicker to figure out where she has to handle something. Then naturally we went to the more central management systems, like large screens, and there the automation was really that you get information aggregation and the automation and visualization of your network and what's going on. So that's sort of where we are, and I think today most of us are still running something like that. Has not much changed fundamentally over the years. So what is changing actually now? One thing is we have a massive push from our customer to be always on. Customers are not willing to accept any interruptions anymore. We actually have internally, we measure our KPIs and downtimes and so on. We're getting better and better. The customers want to have more or more reliability. So that basically means no human invention is possible at all anymore if you are sort of always on. Then many management approaches are based on assumptions from hardware boxes. That comes back to the question I just got here on the EMS. And I brought this picture. So that's sort of the assumption we still have. You have hardware-based network functions, you have some sort of a management agent, you have management software dealing with that piece of hardware. Now, the flexibility in that type of setup is what the management software is doing, because the hardware is pretty fixed. We cannot change anything. But where we move towards, I put it tomorrow, like we see the movement towards, it's slow and so on. But tomorrow we have more programmable hardware, NFVI, as well as switching capabilities, which are more programmable, which basically means you increase the software stack massively, which also means you can actually add much more management software right to the function. It doesn't need to be sort of external at all anymore. This being external was really from the old times where you had problems with the access to the boxes, where you have problems with how much CPU power you had on boxes, and so on and so forth. Still, you need a small piece of software for sort of an end-to-end view. I mean, you still want to know whether your network is up and running and things like that. You want to bring in some of the business policies and so on and so forth. But my belief is that this is sort of changing the situation. Also, what is changing is the cost of compute is decreased quite heavily over time, which basically means you can run much more complex algorithms. I mean, on box, off box, doesn't matter, but it gives the capability to do so. I still remember when I entered the telecom industry, I think we monitored a switch sort of every 15 minutes. And those which remember that, they says something about your age. And there's higher degree of flexibility and agility requirement. I think I heard that in every talk so far at this event. Now, what does that mean for a fully automated operation? On the configuration side, the assumption is that configuration information is actually already in the environment. The functions can fetch that information. That's the way as most of the cloud technologies and IT systems are doing that. Other configuration can actually be implemented directly into code. There is a term like infrastructure as code sort of going through the IT industry. There's not too much this, I need to configure my box thing anymore. A lot of this configuration is really done within the functions. You need to adapt to your environment, sure. You want to adapt to your business policies, but that's it. There's not too much more to do. Self-healing, failures are actually a default. If we want to have an extreme high reliable system, failures are a default. You need to deal with them in a default way. It's not an exception. And there also, the applications or network functions knows best what to do. They are in their domain or they specialized for their function, so they know exactly what to do. Same holds true for optimization capabilities. The application or network function knows exactly what to do best. Many times it's also cheaper to throw resources at the problem than expensive technology. I think that comes a bit out of the internet way of thinking. Many times it's much more cost efficient to put a bit more resources on a problem than they're having extreme complex optimization problems to solve, specifically in large scale. Self-protection is for me one of the big open questions. There are movements around that in the security space, but I've not seen really breakthrough on that. And I'm very interested to hear if somebody has breakthrough on that. And self-care customers are sort of a given for me. So that basically means a bit that the customer makes some of the manual steps. It's not us anymore. He enters what he wants. He enters some configs. He enters something. So that's what he wants. So what are the natural steps towards automation? I put up like three points. I was hearing a lot about closed loop operation. So that must operate on a model of the network, which is a big problem on its own. And we have not, as an industry, not been very good in doing that properly over the last tens of years. Because also, if you have closed loop operation, you need to have predictable actions. If you put an action to the network, you want to predict what that means. If this action is doing something, you want to predict what happens in the network. And that's very difficult to infer. Then there's the hype around artificial intelligence analytics. I think that works quite well for problems which are sort of have a large enough data set to learn. The problem many times in networks is a failure is a rare event. It's extremely difficult to learn this type of failures or predict this type of failures. And then there's this movement from standards to open source. We just had a nice talk about OSM before. Just one benefit here for the administrators of networks we see is if you have open source tooling, people can have a look at what these tools are doing and sort of get more confident about the tooling to really work with them. So if you have this black box type of thinking is bad in that sense. Why are we not there yet? A lot of these technologies are somehow available, but there are a few challenges in the roadblock. One is really, from a commercial side, the return on investment for zero-touch tooling is relatively expensive. Because a lot of this algorithm and so on are complex and they cost. Migration is a challenge for any new technology, no matter what. For zero-touch, it's even many times not possible to do it like at once. You need to have this step-by-step migration. Many times, zero-touch is domain-specific, and we have examples. I put up like IP routing is a good example. It's like an automatic way of doing a routing and failure recovery. You can argue it's not quick enough. You can argue a lot of things, but it's sort of going pretty much automatic in a global network. But it's extreme thin domain. It's a very particular domain where that works. Then there's the culture of operation. So basically people think, so no change is the best, don't change anything. But actually, so then if you talk about flexibility and agility, change is the norm. It's not an exception. So that's a bit of a cultural change needed. We believe also it is required to build in early in the design. So zero touch is something which you need to build in early in a network architecture and designs. It's very difficult to do that as an aftermath. The problem with that is it's naturally sort of an increased upfront development cost you have to take. And there's still this complex legacy network lying in our grounds, keeping us busy for a bit more time than we thought we could. One more thing is, I already heard that in some talks as well, that if you want to do zero touch, you need to split up the elephant in the room. So you basically need to slice it up into more cloud-native software architectures, having small elements working, which are then also able, it's possible to model them easier instead of the big elephant. And you can do more self-healing on small elements than on big elephants. You can even have more ants in this case to replace other ones. So it's for a reliability perspective, that's a very good way of going. So that was sort of more on the technology side. Now some words on the process side. At Swisscom we talk a lot about, we call it the biz DevOps. It's not only DevOps but also taking into account the business part of it. And it's sort of, the model starts at the top right, is like with business planning in one way or another, which is naturally going continuous. If you go in the circle to the right, you have the collaborative development of products and services. You need continuous testing and automation of testing. You need continuous release and deployments, continuous monitoring, and continuous customer feedback and optimization. And this circle sort of is going on. So that's sort of the master process we apply here. Probably one word I've seen that other operators also started to use the Scaled Agile Framework, or SAFe. We start introducing that quite massively as well at the moment. There are a set of teams already last year. Now this year is a massive ramp up into more different organizational setup. From just one word on the organization part. Now, having said that, sort of this agility of developing things, including software, hardware, networks, and so on, we naturally are still in an ecosystem, and we still buy a lot of our equipment from suppliers. So what we really see, if it's about the collaborative development, there needs to be interaction on several levels between suppliers and operators. So basically you need to have, if you really go in, say, CI/CD, fast deployment, fast testing model, this needs to run across different organizational units. In that sense, even across different legal entities with all its problems. And sort of some of it is done today already, other things we are discussing that with some of our suppliers as well. With some it works well, with others they are not ready yet. So there needs to be this interaction for the collaborative development, but also for the other things. For the testing specifically, if you want to continuously deploy, you need to get the code in automated fashion and deploy it continuously. So Swisscom has moved last year to like a monthly release cycle of our software. So if you want to go into this level of release cycles, you better keep up with a more agile way of delivering products. And not sure whether we go one time make the step even into smaller granularity. Unclear at the moment. One word on the automatic testing and the continuous testing, because actually we believe there is a big business benefit in the automation of the testing. And it's something if you do this really quick release cycle, you can almost not do it differently. You cannot spend weeks of testing anymore. You deploy, you test, you deploy it in production, you test in production, and you go on. Next release is coming quick. So there is, if you go like down that path, you need to have a higher automation in testing. And we believe it's a promising cost-saving case. We're not able to prove that so far. Testing is always cumbersome and difficult to do. Testing can happen naturally on various levels, on a VNF level, service level, and so on. Challenges in the network side is the distribution. Looking at in the morning, there was the Telefonica presentation about sort of cord-like deployments. If you have that, you start having a largely distributed test setup, which is a challenge on its own. On the other hand, NFV as such has the benefits of doing a lot of testing, because you have a certain CPU capability, network capability in the NFV. You can run tests relatively easy. You can spin up test elements and run it against your network relatively easy. Much easier than it was in the hardware world. One last thing is really the trust. If you talk with the operational people, they say go away with zero touch and automation. We don't trust all that tooling and so on. So the question is, how do we achieve that? And it's it's more the human-centered perspective on zero touch to build up that trust into a zero touch systems. Same with, I would not feel comfortable at the moment having an autonomous car and sitting there and not looking to the street. The same is with administrators responsible for running a network, or the CTO running the network. He is afraid of going too much automation because things can go wrong all the time. So getting this culture of things go wrong and sort of show that things go wrong, and if the failure is sort of the normal case and you see that the network reacts properly in the failure cases all the time, I think it's one way of sort of giving a more trust into that zero-touch system. I already said administrators tend to believe more in stuff they do themselves. So if the tooling is more open source and they can sort of change things here and there, they sort of embrace that tooling much better, and sort of in that sense also trusting their own work more than if it's a black box. And there is naturally sort of this step-by-step introduction of things. I think in the autonomous car industry, they define something like 4 or 5 levels of autonomy, how self-driving it actually is. So there are several steps in between. I believe in the telecom industry, we probably have something similar, that you have from manual to automatic tooling to sort of closed loop, but humans still press OK, to like small pieces going completely automatic with sort of good monitoring, until people believe that you don't even need monitoring anymore. If failures are going away, it's no problem. Sum it up. So it's very clear that we want more automation. I think that came out in that event very clearly. What it's a bit unclear for me is sort of what are the approaches on the technical side. On the process side, we have made our choices at the moment. We will see how that works out. Softwarization is naturally a key. That's why we also heavily engaged in the NFV things. I've not seen too much on the technical approach side and how feasible they are. From AI, ML, closed loop, and so on. And it might be, as I think somebody was talking yesterday saying, yeah, it's not about technology at all. It's much more only a process thing. that sense, we would be almost done as Swisscom. I personally don't believe that. I think it's a mix of all these different things. We believe automatic testing has a lot of cost benefits, and is sort of a must going into cross-organizational CI/CD pipelines. And with that, I thank you very much for your attention.